Good afternoon and welcome to the 7th in the Integrated Building Design series. We have another one of these next month and we'll be posting, I think, in the chat at the end of this presentation, the details for that, or at least a little teaser. This month, we'll be hearing from Darren Barlow and Vasilis Maroulas from Arup about the Sky Central building project that they were involved with. Darren Barlow is a director of environmental and building services design at Arup, and he is currently engaged in a number of projects that have high standards of sustainability, such as SNF CC, the Fubon A25 Tower in Taipei, and the Whittle Schools and Studios in Shenzhen. Joining us as well is Vasilis Maroulas, who is an associate director at Arup. He is an environmental and building services engineer with a background in mechanical engineering and passive design. Both Vasilis and Darren are strong believers or proponents of the concept of total design. So I'm looking forward to hearing about their work on this project. Before they begin, I will ask that if or when you have questions, that you please post those in the Q&A. We've disabled the chat, but I will be monitoring that Q&A section and will be asking those questions of them at the end. And also note that this presentation is being recorded, so you can go back and watch it again and again. Thanks to both Darren and Vasilis, and I will hand it over to you.
Elizabeth, that's great. Thank you very much. It's great to be invited to deliver this online lecture on integrated design. It's a great series with a number of speakers that have already presented some really exciting projects. And so it's also great that this technology of Zoom's come along to give us the opportunity to share some of our experiences and knowledge about total design, holistic design, multidisciplinary design, and the key integrated design. They're terms that are extensively used around construction, but there's a certain enigma around them. So today, Vaz and I, over the next 30 to 40 minutes, wish to share where our inspiration for integrated design comes from, explore that enigma of integrated design and how we believe it comes about. Which are those moments in the project where the whole becomes greater than the sum of the individual parts, and wish to offer some examples of integrated design that were realized on the Sky Central project, which Vaz will introduce in more detail later in the presentation. And then finally close with sort of sharing perhaps the significance of what integrated design has the potential to do in our changing world in the future. So for Vaz and I, the integrated design has got to start with Ove Arup, the founder of the Arup practice. Ove, as well as an excellent structural engineer, was also a passionate philosopher. And Ove Arup delivered a talk in 1970 to the founding partners of the firm, a time when perhaps integrated design was less common in construction. And in that talk, that talk was intended to be in response to the sort of collective desire for all the facets of the firm to continue to work together, despite the changes that would occur in time as each founding partner retired. In that speech, he refers to both integrated design and total architecture. And the particular elements I like is the term total architecture implies that all relevant design decisions have been considered together and have been integrated into a whole by a well-organized team empowered to fix priorities. This is an ideal which can never or only very rarely be fully realized in practice, but which is well worth striving for artistic wholeness or excellence, and excellence depends on it. And for our own sake, we need to be stimulated to produce by excellence. So, integrated design. What is it and where does it come from? Everyone likes a great diagram. So Vaz and I considered on how on our projects perhaps integrated design comes together. What is it? It's synergies, balance, whole, completeness. This isn't a universally accepted sort of thing to have integrated design on projects. Some believe that actually integrated design can be time consuming, risky, complicated, almost impossible or slow. It's important, therefore, that integrated design or total design delivers outcomes that are greater than the sum of those individual parts. So I'm sure over the course of studies and those on the call have come across studies on integrated design. Vaz and I thought we would share and capture the key components that are fostered on integrated design on our projects, which come through on this diagram. We feel it's important, first of all, technical skill, to be the best that you can be as an individual in your core discipline. Be creative and innovative. Treat each new challenge with an open mind, not be burdened by one particular solution which you may have come across on the last project or otherwise. That doesn't mean forgetting your experience and knowledge that you've gained over your career or past projects. Strive to come up with the best solutions for the brief. Have ownership for the proposals that you make, and not to be frightened by innovation. Having a great trust and deep respect for those that you're collaborating with, a deep interest in other technical disciplines, and understanding their vocabulary, a basic understanding, and their design principles. Being inquisitive about the design developed by those other members of the team, and being prepared to politely challenge and perhaps challenge yourself on your proposals. And a general acceptance that a solution to be considered doesn't need to be fully resolved, but obviously has to be resolvable, and have in the mind a form or a pathway to finding that resolution. And then common vision. Vision can come from any member of the team, and or maybe a collective or created as a collective team. But it's important that the vision is captured and communicated by a statement, a sketch, a diagram, a visualization. And the key is then that for the team to then believe in it and want to achieve it. Environment, well, the environment conducive to integrated design, I've always found, is one of exploration, one in which those that are participating value the potential that can be realized from integrated design. Not too quick to close down on ideas and solutions, but doesn't need to be time consuming or take longer than any other design cycle. And there's a feeling of collaboration and togetherness. And then finally, momentum. I find that responsiveness is important. We should seek to build upon each other's ideas in the direction of that common vision. I find that I end up quite often focusing on design and design solutions, perhaps over the other administration activities, but keeping the momentum moving. All of these elements came together on Sky Central, a project they came together not only once with the collaboration with the team led by architects Amanda Levitt, but on a second time as well with Architects PLP. I hope that we can demonstrate with the integrated design not only delivered great architecture, but high quality workspace and high levels of well-being for Sky's staff. I'm going to hand over to Vaz to introduce and share some of those moments. Thank you, Vaz.
Thank you, Darren. So, Sky Central is a project we completed a few years ago, and we would like to share with you the design journey, and how the integrated building design concept was formed. So our client, Sky, have spent 27 years making TV. They were first to offer digital TV, and they are now have over 34,000 staff in over 130 locations. They have been investing in making places where people work brilliantly and easy across UK and Europe. But in Austerley, where they are currently located in London, is their headquarters. It is where Believing Better started, their motto, their slogan. So they wanted to create a headquarter that everyone, no matter where they are based, could be proud of. So why integration was so important to visualize that vision? Because client and Sky themselves have complex needs, which sometimes they conflict with each other. So the question is how we can satisfy those needs in a seamless way, how we can maximize the potential of the client's vision, and how we can enhance each other's aspirations, the architects, the client, the engineering aspirations. Some key parameters from Sky's strategic visions were a campus which will be highly connected, bring people together via landscape, central amenity, meeting spaces, via food, via restaurants. They wanted a building which would be very flexible to cope and facilitate the ever-changing nature of their business. They wanted to be exemplar on sustainability, both environmental as well as social. So they wanted a building at the outskirts of London that can offer a plethora of high-end amenities as well, so it can attract the best talent. And they did that in a way. They wanted to design a building that was a small town within Arup. Sky appointed Amanda Levet Architects and Arup to design their new headquarters building. We, as Arup, we were appointed to do all engineering. However, when they would start thinking about the form of the building, you know, the city buildings of 15 and 20-story high were budget prohibitive, and therefore the client wanted to come to a more bespoke solution, something which could work also with the urban environment in Austerley, which was at the outskirts of London. What they had in mind was a Bürolandschaft type of office. Here in this image, we look at Johnson Walk's headquarters. An open plan office that accommodates free and open plan furniture scattered in a large, loosely and unstructured divided spaces, less rigid, with creative partitions and plans, the nature of them often dictated by the type and functions of the workers being there. The challenge was that in an arrangement like that, in an open plan arrangement, it is difficult to actually celebrate the structure and conceal the services. It's difficult to bring daylight. It is challenging to actually create a connected environment. It can look quite cramped. And so they traveled to the States to look at similar large-scale office facilities from the creative industry. So in the next slide, we see they visited Pixar building and Facebook headquarters, which were converted factories powered from the sun via photovoltaics with daylighting coming from the roofs. And although they liked those type of buildings, they were concerned with the inhumane nature of those large buildings and the large and long flat plates. So before going to unfold the story of the design, I will give a high-level summary of the design solution, just to give an overview. In Sky Central, we came up with a very long, but a very low-rise building, only 3 stories, a landscraper than a skyscraper. We designed the largest timber roof in Europe, 16,000 square meters, which integrated skylights. areas at high level that we could collect the hot air, and 12,000 square meters of photovoltaics on the roof to generate electricity. We allowed the daylight to penetrate from roof skylights and percolate down to lower roof levels via a series of atria scattered in the floor plates. We did the opposite with ventilation. We bring fresh air into the space from the floor and allow the air to rise up to the ceilings. By adopting this approach, we managed to clear up all services at high level, celebrate the structure. We will now see in the following slides how we slowly unfolded the design of that solution. So ALA's vision, Amanda Levette's architect's vision, and response to Sky's needs and concerns was to create neighborhoods within the building to provide some demarcation for the vast landscape floors. With that in mind, the use of Vetria came up to break the long flat plates, as well as to create vertical sight lines from one floor to the floor below or above. And that was a vision that all design team members shared. In a way, it was a piece of a Jenga game of office, aiming to optimize the location of that atria to actually get the most out of daylight, ventilation, and sight lines, so provide ease of connectivity between the floor plates. And so, from an engineering perspective, the first idea is to bring daylight from the top to create a fully daylit space at the top floor, and then utilize multiple atria to bring daylight to the lower floors. They would not be as daily as the top, but the idea is that every floor to have access to daylight and be able to see the sky. So punching skylights through the extensive roofs allows maximum penetration of daylight into the building, providing even dispersions across the floor plates, as we see in the next slide. Floor openings are distributed throughout the first and second floors, increasing in quantity as one ascends the building. In the next slide, we see here how these atria permit visual connections across the large expanses, vertically as well as horizontally. Moreover, it allows the natural daylight from the roof lights to percolate down through the roofs, through the floors to the ground floor. The next challenge was that in an office space of a TV broadcasting firm serving 3,500 people, the workstations are heavily used. Each employee has 3, 4, sometimes 5 screens, which generate a lot of high internal loads. And that poses a significant challenge on how to serve those desks. Therefore, a conventional and typical high-level fan coil approach, like the one we see in these images, would have resulted in a quite congested and aesthetically unpleasant ceiling. So a different approach was needed. Therefore, we thought to propose a bottom-up supply of air. In other words, what we call displacement ventilation. This means that the floor void was pressurized with air, and air was supplied into the space via floor diffusers, which I think we can see in that blue carpet in this image. This means that the floor void was pressurized with this. The displacement system would then be responsible to deal with heating, cooling, and ventilation. And therefore, it removes all HVAC services from high level. A pure displacement ventilation system is predominantly being used in other building typologies, in theaters and galleries. But here we are transferring that technology across to an office building. The air would supply it from the floor at very low velocities. And the benefit of that is that it provides maximum flexibility to the architects as designers, but also to the users to locate their seats and desks close to the floor outlets without the risk of cold drafts without the risk of cold air reaching the low part of our bodies. Now, how does displacement ventilation integrate with architecture and the architectural vision? I mean, we already mentioned the clean soffits that it allows for celebrating the structure. It also provides maximum flexibility. But for the displacement ventilation also to work effectively, it requires tall floor to ceiling heights, not the usual 3.5 meters. But here we designed the floor to ceiling heights at 4.5, 5, even up to 6 meters on the second floor. From an architectural point of view, tall floor to ceiling is desirable to optimize the proportions of the long and deep floor plates. And in addition to that, it helps with vertical sight lines from the one floor to the other. And so what I'm trying to say here is that the engineering principles that we put forward enhanced the architectural design intent by augmenting the volume and height of each floor plate. So the two things were coming together and working together, architecture and engineering, very seamlessly. The idea, so just to bring it back to the principle, was to create a long and deep office building, 170 meters in one dimension and 90 meters long in the other. And the structure played a key role in achieving an integrated low carbon design and low carbon building. So a concrete structure, we designed a concrete structure predominantly with 6 concrete cores, which meant to play a fantastically important role in the success of this building. We also designed flat slabs. The roof structure is formed from glue laminated timber beams, though, spanning approximately 20 meters, allowing for large column-free areas on the second floor. So here we have a combination of lightweight roof with concrete cores to accommodate services and plant rooms at the top of the cores. Another important and valuable design moment in relation to the structural design was how the services would be integrated with the structure. We looked into many options during the concept design, but eventually we narrowed them down to a composite metal deck with primary steel frame structure on the left-hand side and a reinforced concrete option with flat slabs on the right-hand side. A metal deck solution has deeper structure and works well with building services at high level, more of a conventional solution. With a concrete flat slab, services running in the floor voids work more seamlessly. And due to the ease of construction, program implication, integration of services, but also allowance to expose the structure at high level, whether it was the timber roof or the thermal mass of the exposed concrete at lower levels, the flat concrete sub-solution was preferred. And as I said, this was an important moment at the design integration journey because it allowed the low-level services allowed to celebrate both the timber glulam beams at the roof as well as the concrete floor slab. The next thing we needed to look at was the core arrangement. The cores play a very important role into our design. 2 slides before. The key idea is to open up the staircase to the floor plate, thus creating an open, single fire compartment throughout the entire volume. On defining the core locations, which we can see here, the volumes of the core are separated into a public and private arrangement. So in the next slide, we will see at the far back end is one of the main cores of the building. The public volume serves the stairwell and lifts, providing open double height spaces to create strong visual connections between one floor to the other. The cores also accommodate all vertical services distribution, as well as back of house spaces. All these white walls that we see at the far back is back of house spaces and risers. And so that allows the whole floor plate to actually be dedicated to the employees, to Sky employees, to the users. So to conclude, that was a design journey during concept and scheme design with a design team which shared the same vision. There was a lot of trust amongst the design team members and the client to develop innovative and progressive ideas using a lot of testing and modeling to prove the technical feasibility of those options. So we created a building, a quite deep building, which was also day-lit. We worked for both, we worked with a ventilation system that worked both for architecture and engineering and managed to maximize the volume and the height of the buildings to improve the perceptions for the occupants who live in. The structures and services coordinations worked seamlessly to satisfy and meet the design intent, the architectural design intent. And we engineered the course of the building in such a way to concentrate all services within the course and free up the floor plates. So my last slide before I pass on to Darren, the design had been developed sufficiently at that time towards the end of scheme design for the client to have sufficient trust and confidence to take the project out to the market and tender it. And so now we'll pass on to Darren, who is going to explore how the design was continued and how the project was taken into construction and handover. Over to you, Darren.
Thank you, Vaz. So Sky were truly happy with the scheme that the Vaz and the team with ALA had created, but as Vaz explained, that some circumstances had changed within the Sky organization, which meant that actually there was an eagerness to try and complete the headquarters building ahead of time. And Sky, so they appointed their own in-house development team and decided to accelerate the procurement and construction. They invited 2 contractors, as Vaz mentioned, based upon the early stage sort of concept information that the ALA and Arup team had created. And by the time they'd reached the scheme design, Mace Construction had, and along with PLP Architects, had been appointed as the design and build team. And Arup were to be novated across on completion of the scheme design, and just novation is a means for Sky, the client, to be able to transfer the engineering team from the ALA team across to Mace and PLP as the development and construction team. And this was the sort of start of my journey of Sky Central. So I worked with PLP and Mace, who we rigorously sort of tested the original design concept against the brief and drew great parallels with the ALA design. The one area where PLP and our team identified as an opportunity to further enhance the scheme was in the creation of more sort of horizontal, diametric visual connections between the floor plates, and to create more serendipitous encounters between Sky's highly talented employees and sort of diverse staff. And Sky felt this was an important contribution to their ongoing innovation of their business, to have interaction between different departments so that they continue to advance and in both their technology and services. So in parallel with the final elements of Vaz and the ALA team working through, Mace, PLP and I, with a small team from Arup, began to develop a parallel scheme for exploring this opportunity for more serendipitous and chance encounters across the building. And it was largely centered around the views and the cores. So the ALA scheme promoted quite inward and cross floor and between floor views through the town square in the center of the building, and there's a wonderful simplicity within that concept. PLP wanted to broaden that visual connectivity to create diametric views across the building, which would extend more than 100 meters. This was one move that created a new vision and a further turning point for the building, and the start of a sort of a new journey. And the realization of this could really only be achieved by significantly reducing the cores, which are represented as the grey squares on these diagrams, with the vision represented in the green views. So to reduce the core, what was in them? As I mentioned, their wonderful simplicity of the 6 cores across the building. They contain the building services, the vertical circulation, the toilets, welfare facilities, storage, and Sky's important sort of resilient data and technology services that were serving all the office floors themselves. And the key was the cores were also, as a traditional building, were, although open, were providing the means for all 3,600 staff on the office floor plates to evacuate. And so they were evenly spaced and well spaced out, which again provides a level of resilience for people to evacuate the building in the event of a problem. So in order to get to smaller cores, it was only really made possible by taking reference from other large volume spaces like this image of Heathrow, taking reference from airports and hospitals. And in these types of buildings, there's an accepted level of horizontal evacuation, people moving horizontally before they then travel down through the building. And so they can move away, people can move away from the potential risk before then exiting. So this actually gave us the idea to locate the stairs and the cores into the central atrium space and start opening up the floor plates themselves. This early evacuation model begins to indicate how Sky staff would move across the floor and down through ramps and stairs to escape the building. And this fire engineered approach, the evacuation model was to simulate people could evacuate the building. At the same time, we had another model, which was a computational fluid dynamic model of a representation of a fire generating smoke. And the key strategy for the fire engineered approach was that everyone needed to be able to exit the building before the smoke would obscure the evacuation routes, which were all now centered within a single central atrium space. So this pioneering fire engineering approach unlocked the solution of being able to take the stairs and lifts from the cores and into a common atrium area. And this was largely embraced by Sky, largely through engagement. That it was of benefit that the skill of the health and safety manager at Sky, they'd worked in airports, and so they understood the principles of horizontal evacuation, and were confident that Sky as an organization could put in place an effective management plan to allow people to safely escape under those conditions. And so this principle was agreed, and the realization of this new vision needed to draw upon the sort of highest level of skills, not only from the fire engineer, but also from all the members of the team and the client organization themselves. So the reconciliation of the design needed to draw upon the highest skills. So this included the HVAC needed to be rationalized, the vertical services distribution that Vaz introduced ultimately needed to be condensed down. That meant rerunning thermal comfort models and reappraising the displacement ventilation. The daylighting and the lighting scheme retested, and we integrated additional roof lights to elevate the lighting levels within the central atrium space to penetrate down further down into the ground floor. The acoustic consultant was challenged by the openness and the line of sound propagation through the building, and so we developed responses to tackle that. And the electrical engineers in delivering a fire engineered solution enhanced the existing fire alarm system and smoke detection system with a dynamic fire evacuation signage scheme, which allows the first implementation of this in any commercial building in the world, actually, where you can use the evacuation signage to direct people around the building to help that evacuation process. So each design team, or each member of the design team, took on the challenge, and there was great trust in that those concepts that were identified as a team at the early stage within the vision could be realized through the design. And the shift to the smaller cores allowed the fire escapes, as I mentioned before, to be located inside the atrium, giving staff even greater visual connection while circulating around the building. And the volume in the atrium therefore allowed ramps to be introduced, stairs to be elongated, and increase the probability of those chance encounters and the serendipity of those encounters, which was founded within that original brief. It allowed disabled people to traverse floors without the use of any lifts, and make the office an even more inclusive workspace. And those visual connections within the building across the atrium allowed the hierarchy to be completely reprioritized. So we moved the lifts from the entrance point of the building and moved them away from the entrance deliberately to prioritize the use of stairs, to encourage people to use those stairs and ramps to promote exercise and well-being. And so the red stairs and circulation paths were realized within the atrium space. This was at a time when we developed the concept just as the ALA scheme was coming to an end. So we had two schemes that were converging at one time. Vaz and the rest of the Arup team, we merged as a group under the guidance of the contractor, and the drive to get the project underway in terms of construction at the same time as having these two scheme designs. So traditionally a sort of under modern REBA stages around about stage 3, we were actually also preparing structural tender drawings for pricing the main structure of the building, and the foundation drawings were already being issued for construction, And in fact, 5 weeks after we'd finished that stage 3 design, the foundations and the piling were actually commenced on site. So we entered into a stage where design and construction were very much running in parallel, so that the design was being prepared and finalized just in time for it to be effectively implemented at a construction level. But this collaboration with working with the contractor allowed us to also explore opportunities around prefabrication techniques, and within the final design we integrated multi-service corridor units and the whole of the energy center that supports the development and actually harnesses heat from an existing energy center were all modular in construction, to again take advantage of the collaboration with the contractor, but also accelerate the construction program. And that extended through to the roof. The glulam beams, there's nearly 6 kilometers of total length of glulam beams within the building, and saving up to around 2,000 tons of CO embodied carbon, compared with perhaps a conventional roof structure. These all allowed us to complete the total construction within 25 months from breaking ground, which is quick for a building of this scale. And then 4 months later, we had completed the Cat B, the final fit out of the building for Sky, ready to move in. Baz introduced the sustainability criteria. We realised the brief, achieving a 50% improvement in reduction of carbon emissions against building regulations at the time, and better than the current London plan. We repurposed the waste heat that was being generated by a biomass CHP plant on site, by harnessing that and utilizing it within our development, both to create heat but also to repurpose it through absorption to create absorption chillers to create cooling for the building as well. We generate the Vaz introduced, there's nearly 700 kilowatts of peak power, or nearly 20% of the peak building power demand delivered by photovoltaics on the top of the building. That's sort of power equivalent to perhaps around 250 homes. And we also collected water, and so we preserved water and stormwater and recycled that through a rainwater harvesting scheme that then supplied the rest of the building. So integrated design played a key part to Sky's success and realization. In the future, we believe, and we still strongly believe, that it's important for going forward. Our world's constantly changing at unprecedented rates, and so integrated design can create tremendous value for our buildings, our lives, our well-being, and even our planet. And so, coming back to technical skill, there is increasing complexity within the built environment. There's a greater number of specialists involved in coming up with design solutions. And so smart buildings, ecologists, wellness consultants, neurodiversity specialists, integrated design is the opportunity to engage within a dialogue and to bring those elements together. Trust and respect, increasing need for respect for diversity, inclusion and collaboration, and therefore an important opportunity and value to bring in the contributions of all the team members. And vision, we need to work together to solve some of humanity's toughest challenges in the coming years. There's a consciousness and therefore a vision that needs to be achieved. Our integrated design has the opportunity to shape a wider vision, which is to tackle climate change and restoration of our ecosystems. The vision there is also around a one planet living, there's limits to the resources that we can consume, and the need around adopting circular economy principles. And so, as building environmental specialists, we need to continue to work together with the other members of the team to follow the visions of organisations like the UK's Green Buildings Council, LETI, the Better Building Partnership, and the great work and organisation of the likes of the Ellen MacArthur Foundation. And clients are demanding us that we realise this as a profession that takes integrated design to help them realise their commitments to their shareholders, their commitments to the environment, and to the occupants and of the building, and the quality and the well-being of the building themselves. And then time and momentum. Well, the pandemic's demonstrated that the fragility of mankind, and perhaps climate change is the silently impacting all of our communities, and therefore integrated design is time bound. We need to continue to design solutions that will allow mankind to share the planet and all of its indigenous inhabitants. So it's a great opportunity. We could say that integrated design has moved us from qualitative value perhaps to a sustainable necessity. And for our own sake, we need integrated design to also stimulate and produce excellence, which we all should be continuing to pursue. So I hope that's been of interest, and I guess I open it back to you, Elizabeth, for any questions or to the floor.
Great. Thanks, Darren and Vasilis. It was great. We do have a few questions to start with. A couple from Stephanie Gauthier. She asks, they're both related to sort of individual environment and control. The first one is about the acoustic comfort at those desks in the open spaces, and maybe related to that is how those desk spaces were allocated to hot desk, permanent. How much control did occupants have over their personal environment?
Shall I take a bit of that, Vaz? So at the part of the brief was to help create a more agile way of working for Sky, and there are, I think, something like 5,000. I want to say something like 5,400 workstations across the building. Some of them are allocated as, if you like, allocated workspace. But there's only 3,600 people in the building at any one time. So there is an embracement within Sky's organisation to choose locations as to selecting the right place to work for the right activity that you're doing. But the overarching structure is that they're in communities that then can continue to engage in particular workflows or projects together.
And sort of specifically, how was the acoustic performance of that space in the end? Do you know?
So yes, so in fact, the underfloor displacement made the ambient noise levels very, very low, and actually at one stage we were looking at putting in some white noise generation to actually create some background noise. There is the atrium itself as a sound source. We managed that, and actually within the image on the screen there are acoustic absorption on the faces of the atrium, which allow a level of absorption. But actually, I think that there is a little bit of noise still that you get from the atrium, but actually it brings a level of life that everyone within Sky seems to. There are quiet booths if people particularly need to concentrate, but actually it's almost part of the environment. But it's part of the environment that the staff seem to enjoy, and actually
Great, thank you. And then we have a couple of sort of design process related questions from Dylan Webb. First, he'd like to thank you for sharing your process with us. He asked that I would imagine that the design process would have had some conflict of vision at some point. How were conflicts resolved, and what did you learn as a result of that? And then how long did the design phase of this project last? It sounds like there were sort of 2 design phases, but maybe something about that.
Darren, should I take that?
If you don't, yeah.
Yeah, thanks. It's a really good question, and indeed there was conflict. There was conflict, and there was conflict also between us and the architects and the client. But it was actually conflict that was creative at the end, because we had an architect who wanted to listen to his engineers. An engineering team, if I may say, that understood architecture and understood the architecture of those 2 particular architects. So we have worked with ALA and PLP for many years, who understood what they wanted to achieve. And we also had a client who was making decision. And we were having workshops all together at the design stage. The upper floor of ALA's office, we were actually spending hours designing and testing solutions and applying a lot of rationale in the decision-making process, investigating all the options and all the parameters and trying to qualitatively or quantitatively assess those. And then the client was there, and he was intervening, and he was making decision. So we were all part of the same process. But there was more conflict, if I may say, at the later stage. And as we all know that we have worked in the construction industry, that stages 4 and stages 5, there can be a lot of conflict. The contractor comes on board. It's a lot about the cost. We were also working for the contractor, not for the client anymore. How do we serve the needs of the client if you don't work for the client? And it was that time that the attitude of the team is important, and the ownership. That was the massive lesson that I learned. How important is that each and every architect and engineer feel that this is their own project. That's their own, if I may say, baby, that they need to make it grow up. They need to make it happen. And we had a team from the very beginning. We were very fortunate. From the very beginning to the very end, it was the same team. And that very same team wanted to see that building being built. And so all their interest, all their heart was into the project. And I think ownership, I would say, it's probably so important, enabling the people to own and work and feel that it is their design, it is their thing, rather than someone else that tells them what to do, if I may say. In terms of the design process, I don't know if it sounded long. It was a fantastically fast track, and that was actually one of the successes. It actually, we started designing stage A and B at that time, the old RIBA stages, in April, May, and Mace was the contractor. They started works on site in February next year. So in less than a year, we started to work on site, and we carry on designing for another 3-4 months. The total design was just over a year, the whole design process. It was very fast track.
Yeah, that's well delivered. Question here from an attendee. Thanks for a fantastic and inspiring presentation. And they want to know if any qualitative methods of engagement were used to directly integrate end user needs and desires into the early design process.
I suppose you meant right, qualitative. You need to say qualitative, not quantitative.
Yeah, sorry, were any qualitatives? Yeah.
Yeah, no, you said qualitative, and I'm also reading the question as well. But there was a lot of quantitative, but it was a lot of qualitative as the users, the client also visited, as I said. There's a lot of offices in the States, similar offices, and they tried to understand the experience. And this was generated feedback. That was a significant time when they set the vision, that realized that we would like our end users our Sky employees, they need to integrate. They change a lot the way they work, and so we need a building that is very flexible, but also a building that breaks down those vast offices and those very heavily serviced office plates, and how we can make them a place you want to be. You want to wake up in the morning and want to be there. And that was a quality. All that was qualitative. It was, you know, their vision described, their needs described to us, which actually enabled ALA architects and ourselves to actually build up the vision and actually the first ideas.
Vaz, I would add that the context was also that that Amanda Levitt with Arup had actually designed a smaller building similar in some of the concepts on the same Sky campus, and actually we did have some data and feedback from that as well that fed into the Sky brief. So we if you like, we created almost a prototype of the building that Sky were already occupying before we launched into a scaled up version of this nature. So yes, we did, and I'm pleased to say that relationship continues with Sky, and they continue excuse me, they continue to regularly engage with their staff to gain feedback on their quality of environment and meeting their needs.
So along those lines, have you been able, or have they, I know this is always the dream, but has a post-occupancy evaluation been done or planned to be done?
It has, but it's been done by Sky themselves rather than Arup.
Will they share that with you though, for your learning purposes?
They do typically through the briefing process rather than the raw data.
Yeah. Okay. Well, it's something, I guess. But
I mean, what Darren said in terms of POE, they also carried out POEs in the small building that we did, and there was concerns about cold drafts, how the ventilation system works, how flexible it is, and they shared those with us when we designed the Sky Central, the bigger building. Yep. So that's why we actually. There was an evolution in the for example in the ventilation system and in the daylighting from what we had before in the first scheme to the second, and that took into consideration their experience in the first building. That's why actually in the second, if I may say, was almost no complaints, actually no complaints from the ventilation system and its risks, if you like.
That's great that you had
that reflected to them.
Yeah, had that prototype. One last question, and then it will be, our time's up, but did the building get any kind of green certification, or was it trying for it?
Yes, it achieved BREEAM Excellent, and with relatively high score, I would say, for BREEAM, but I would say that came very naturally. I mean, it wasn't any significant, we didn't place any particular effort to get the credits. I think we focused into the design, and when the design was there, when we had, completed in a way the key ideas, we had the key ideas on the table, then BREEAM Excellent just fall in place in a way, which is probably the way I would suggest to address this kind of thing.
And the motivations were slightly, there was less focus on a desire for certification. The building was recognised by the BCO after presenting in 2016 it received Best Workplace through a series of metrics and through the presentation of the building. Sky haven't been focused necessarily on achieving certification, but clearly value the quality of work environment.
Yeah, that's great. I appreciated your presentation. It looks like many other people did. It's always good to see good work being done. So thank you very much. And to attendees, I think there'll be some more information coming soon about next month's presentation, and we'll sort of virtually thank our speakers. So. Thanks.
Thank you for the invitation, Elizabeth. And if there are any questions that are left unanswered on the chat, then we would be more than happy to go back and share answers with UCL and the Bartlett organisation.
Great.
Thank you.
Thank you very much.
Elizabeth.
All right.
Thank you.
Bye-bye.